Whether you're a tech enthusiast, industry professional, or just curious about the future of AI Agents Unleashed will keep you informed and inspired. Buckle up and get ready to unleash the potential of AI.
Welcome to the Deep Dive. Today, we're going deep into AI agents. You know, those things that are like ChatGPT, but a million times smarter. They can reason, plan, like they have an actual brain.
Yeah, they're not just responding to prompts anymore. They're like figuring things out on their own, using tools, even working together to solve problems.
It's like they're learning to think like us, right?
It's a huge leap, really.
So we've got a ton of research here, a whole stack.
Oh, yeah.
All about how these AI agents work, the different ways they're built, what they're good at, and where things might be headed. I'm really excited to kind of unpack all this.
It's fascinating stuff. The whole field is exploding right now.
So let's start with the basics. What exactly is an AI agent? I mean, how is it different from just like a really good chatbot?
Okay, so imagine you take a large language model, something like GPT-4.
Okay.
But instead of just giving it prompts, you give it a brain, a way to understand the world, make decisions, and then actually take action.
So it's not just passively waiting for instructions. It's actually like thinking and doing things on its own.
Exactly. And there are two main ways these agents are built. Single agent, where one AI does everything, and multi-agent, where like teams of AIs work together.
Oh, wow. Teams of AI. We'll have to get into that later. But first, let's talk about those single agent stars. Like, what are they good at? What are their limitations?
Well, one of the early successes was this architecture called REACT, which stands for Reason plus Act. It basically thinks through a problem, tries something, sees what happens, and then repeats until it figures it out.
Like a trial and error learner.
Yeah, and it's surprisingly accurate. They tested it on a data set called Hotpot QA, and it only made stuff up like 6% of the time. But it does have a tendency to get stuck sometimes, repeating the same thing over and over.
So it's good at learning from its mistakes, but maybe needs a little help staying on track.
Right, and that's where architectures like Raise come in. Raise is like React, but it adds memory components so it can remember what it's tried before. So it has a better working memory.
Exactly, which lets it handle longer conversations, more complex tasks, that sort of thing. They even found you can fine-tune it to do specific jobs, even with a smaller language model.
But does it still have those hallucination problems where it like makes up facts?
Yeah, it can still happen, and it can also struggle with really complicated logic. It's a bit like it's overconfident sometimes.
Interesting. So memory helps, but it's not a magic bullet. Now, what about those AI agents that are actually doing things in the real world, not just in simulations?
Right. Well, there's this architecture called AutoGPT plus P, which stands for planning, and it's designed to control robots using plain English.
Whoa, really?
Yeah. Like you could tell it to make a sandwich.
That's amazing.
And it would actually use image recognition to find the bread, the knife, everything, and then plan out the steps to actually make it.
Wow. That's impressive. So how does it actually work? Like, how does it connect the language to the physical actions?
It uses image recognition to, like, identify objects.
And then a language model to figure out what to do. It even uses a classical planner alongside the language model to control the robot.
Fascinating. But, I mean, the real world is messy, right? There must be some challenges.
Oh, absolutely. It can have trouble picking the right tool for a job sometimes, and if it gets stuck, it doesn't really know how to ask for help.
It still needs a bit of that human common sense, huh?
Yeah. It's great at planning, but it can miss the obvious sometimes. Oh, and then there's LATS, Language Agent Tree Search. It's a bit different. Instead of just trying things out, it creates this tree-like structure in its mind
Okay.
to explore all the possible outcomes of its actions, kind of like how a chess AI works.
So it's thinking several steps ahead.
Yeah, it's very accurate, but it takes a lot of computing power and time to do that. It's definitely a trade-off.
I see. So we've got all these different single-agent architectures, each with their own strengths and weaknesses. But what happens when you need a whole team of AI agents working together? Do they just descend into chaos, or can they actually coordinate effectively?
That's where we get into the world of multi-agent architectures. It's a whole other level of complexity, and that's where we'll pick up next time.
Can't wait. Join us next time as we explore the world of multi-agent AI systems right here on The Deep Dive.
So when we start talking about multi-agent systems, things get, well, more interesting. It's like going from a solo artist to a whole band.
Yeah, last time we talked about these AI agents as having a brain, able to reason and act on their own. Now we're talking teams of these brains. That's got to be tough to coordinate.
It is, it is. One of the biggest questions is how do you structure these teams, right?
Yeah, like should it be like a company with a boss and different departments, or more like a study group where everyone's equal?
That's the big question. Vertical versus horizontal teams each has its pros and cons.
Okay, so break it down for me. What's the difference between a vertical and a horizontal AI team?
Okay, so vertical is like, imagine a company.
Yeah.
You've got the CEO at the top, then marketing, sales, engineering, all reporting up, clear chain of command. Horizontal is more like a team of colleagues, all working together, everyone has equal say.
Got it. So vertical is about efficiency, horizontal is more about like flexibility.
Exactly. And what's fascinating is that researchers are finding both have their strengths.
Oh, really?
Yeah, they did this study with these embodied LLMs. So these are agents that can like control robots, interact with the physical world. And they found that the teams with a leader, they were almost 10% faster at completing tasks.
Wow. So even AI benefits from good leadership. Who knew?
Right. Apparently having someone to provide direction really helps, even when you're talking about AI. And get this, the teams led by humans were even more effective.
Oh, interesting. So we still have a role to play in this AI-powered future.
Absolutely. Our ability to adapt, to think strategically, make those judgment calls, that's still crucial. It's like the best results come from combining human smarts with AI power.
It's all about finding the right balance, I guess.
Yeah.
So are there any examples of like actual AI architectures that use these different team structures?
Yeah, for sure. So there's one called DILLAN, stands for Dynamic LLM Agent Network. It's like a talent scout for AI agents.
What do you mean?
It watches how each agent performs on a task, and then it picks only the best ones for the next round, like building a team of AI all-stars.
That's pretty cool. So it's always optimizing for performance.
Exactly. And it's especially good for tasks that require a lot of reasoning, like code generation.
Makes sense. You want the best of the best for that. Now, I'm curious, how do these teams actually plan and execute their tasks? Is it just chaos, or is there some kind of structure?
Some are definitely more structured than others. There's one called Agent Verse. It has very specific phases.
Oh, wait.
First, recruitment. They assemble the right team for the job. Then planning. Then each agent acts independently.
Yep.
And finally, they evaluate how it all went. Very organized.
So it's like a well-oiled machine. Everyone knows their role.
Right, and they found that vertical teams were better when the tasks had clear responsibilities, but horizontal teams were better for more collaborative tasks where you need everyone's input.
So again, choosing the right structure is key.
Yep. You know, one thing that's always bugged me about multi-agent systems is, wouldn't there be a ton of communication? Like all these AIs talking back and forth, wouldn't that just be inefficient?
Yeah, that's what I was thinking. It'd be like a room full of people all talking at once.
Exactly. But some architectures are designed to minimize that.
Oh, good. How do they do that?
Well, like MetaGPT, for example. It tries to get agents to produce structured outputs, like documents or diagrams, instead of just endless text.
So it's like, show me your work, not just talk about it.
Exactly. And it uses this publish-subscribe method.
What's that?
So all the agents share information in one central place, but each agent only sees what's relevant to their task, like a personalized newsfeed.
Ah, that's smart. So they're collaborating, but not drowning in information.
Right. There are tons of other cool architectures out there, but, there are also some big challenges.
Oh, yeah. Like what kind of challenges? So last time we were talking about how multi-agent AI systems can be structured and some of the challenges they face.
Right, right.
You mentioned that there are some pretty big hurdles to like creating AI agents that are even more powerful and reliable.
Yeah, one of the toughest ones right now is how do we evaluate these agents? Like, how do we know how good they really are?
Oh, right. Like how do we measure their performance?
Yeah.
That makes sense.
With language models, it's easier. You've got benchmarks like MMLU and GSM-8K, those kind of things.
Right. Like standardized tests for language models.
Exactly. But for AI agents, there's no real standard yet. Everyone's using their own custom tests, so it's hard to compare different approaches.
Ah, I see. So it's like trying to compare apples and oranges.
Pretty much. So researchers are trying to come up with like objective and automated ways to test these agents, benchmarks that are fair and comprehensive.
So we can really see what they're capable of. Is that the main challenge then?
Well, there's also this issue of data contamination.
Data contamination. What's that?
So these language models, they're trained on huge amounts of text and code, right?
Right.
Sometimes that data overlaps with the benchmark questions.
Oh, so it's like the AI is getting a sneak peek at the test answers.
Yeah, exactly. So researchers have to be really careful to make sure the tests are like truly testing the AI's abilities and not just its memory.
That makes sense. It's like making sure that students aren't cheating on the exam.
Hmm.
Are there any other challenges that are like top of mind for researchers in this area?
Yeah, a big one is like, how do these AI agents perform in the real world? Outside those controlled lab
Right,
environments.
because the real world is a lot messier than a lab, right?
Totally. Like a lot of the benchmarks now are logic puzzles or games, which are good for testing reasoning skills,
Hmm.
but they don't really capture the complexity of like real world situations.
Yeah, the real world throws you curveballs.
Exactly. So we need to see how these AI agents deal with unexpected events, with ambiguous instructions, with like working with real people.
So we need to take them out of the sandbox and into the wild.
Exactly. That's where the real test is going to be.
It's exciting and a little bit scary to think about all the possibilities.
It is. It's like we're on the verge of this whole new era of like partnership between humans and AI.
Yeah, but like you said, there are challenges, and we need to make sure we're developing these technologies responsibly.
Absolutely. It's up to us to shape how AI evolves and make sure it's used for good.
Well said. And for everyone listening, what do you think? What problems could AI agents help solve in your life? What possibilities do you see? Think about it. You might just come up with the next big breakthrough. Thanks for joining us on this deep dive into the world of AI agents.
It's been a pleasure.